Now the next question could be, why do we need etcd? Why not just use a normal database? Now to answer that, we need to understand the problems distributed systems face. So the very first problem is the no single source of truth. So in a distributed system, you don't have one machine. You have many services running across many servers. Each service may need to access some shared information. So for example, the configuration, the cluster membership, or the leadership information. But if every service stores that information locally, right? So if we don't use any etcd, and how the service would be storing the configuration? So the service might store the configuration in its local. So for example, service A stores this configuration, the feature X is enabled. So this is the default configuration which you do in the application.properties. So you don't know, in service B this might be a different owner. So in this case, the owner could give the property value as feature X is equal to false. Now imagine service A thinks feature is enabled and service B thinks feature is disabled. So that's how the distributed systems fail. We need a centralized, reliable, strong, consistent source of truth. That's exactly why etcd exists. The second problem is strong consistency requirements. You might ask, why not just use MySQL or Postgres? Remember, databases are great for application data, but etcd solves a different problem. In distributed coordination, correctness is more important than performance. So in case if you have to use the database, so what you have to do to achieve the strong consistency? So you have to ensure the different isolation levels and ensure you always do the read committed mode. And again, it depends on database. And first of all, this is not the kind of huge information you need database. Database provides so many things, but this is a very tiny information, very configuration, cluster metadata. So for this information, you would be setting up a huge database that would be consuming a lot of resources. So you don't need any DB related functionalities as such. And you don't want to install that much heavy software on your machine or any of the machine, and you would try to make it fail over by spinning up another machine. So what etcd do is, etcd provides a simple 3 nodes, 5 nodes cluster you can easily install on your nodes, and you can get the strong consistency out of the box. So it doesn't need that much heavy software or that much heavy tuning. And let's say, for example, you have used the database as well to make it scalable. If your scale is so much, right? So what you would do is, there would be a write instance and there could be many read replicas. These are the read replicas. So what would be happening? So the write queries would always be going to the primary instance, but your read queries can go to any of the read replica. And these read replicas might have some stale data, right? Which is not replicated into this read instances. So for example, if you are doing immediate read after the write, you might see the stale data. So you don't have the strong consistency in the database. Now, but in etcd, what you have is, you have the 3 node cluster, right? And as I mentioned, how etcd do the strong consistency. So whenever the write request comes to this etcd, so what it does is, it replicates the data to the followers as and then immediately, right? And then only it would be responding back to the client that okay, the data has been written successfully. It works on raft consensus algorithm. So majority of nodes agree to this data, and then only it would write that information, and this is happening via the quorum based consensus raft algorithm. So that is how etcd guarantees this strong consistency. Now the third problem is the leader election. In distributed systems, many tasks must be executed by one instance. So for example, you have the order service, right? And you have the 3 instances in this case, and you might have some pending messages in your order service database. So what would be doing? Order service would be processing these messages. So you might have some scheduler which would be running in this service. But would you run the scheduler in all the 3 instances? Now it would be a duplicate effort because all the schedulers would be starting in all the three different instances and doing the same kind of work. So you don't want all of your instances should run this scheduler at the same time. Only one instance can run the scheduler, and that instance could be the leader instance. So similar to this leader example, there could be many other real examples, right? So as I mentioned, the database primary node. So for example, you have the database, right? Now, if you want to know which is the primary node, right? So you can store that configuration in etcd, right? With that, you would easily come to know that whether this is the primary or this is the primary, right? So you can have this type of information also in etcd. Now, the next question could be, how do multiple nodes decide who should be the leader? So for example, in this case, there are three instances of the order service. Who would decide who should be the leader? So for this, etcd provides a distributed lock and election mechanism. So what would be happening as and when the order service is coming up? Let's say the order service instances are worker A, worker B, and worker C. These are the workers for this order service, right? So what they would be doing is they would be competing for leadership using a lease. So when I say leadership, so that means they have to create some key into the etcd, right? So for example, the key could be like services, order, and the leader. This key is present, that means the leader is already active, right? So what would be happening is, as and when the services are coming up, so all the workers would be competing for the leadership lease. When I say lease, it could be for a limited time. So for example, for 10 seconds. So the worker A, let's say, acquires the lease for 10 seconds. Now what it will do is, it will write this key, right? And it will write its name, that the worker A is the leader. Now whenever this has happened, so all the workers, worker B and worker C, these would be notified via the watch mechanism, which I will be explaining later. The worker B and worker C would come to know that, okay, the leader is already selected, so they won't go for any leadership lease. And even if they go, the key is already there. If the key is there, there should not be any other key for this order service leader. And if the leader crashes, so for example, what would be happening is, worker A would be kind of continuously, after every 10 seconds, it would be continuously sending the heartbeat to this etcd. As and when the worker A dies, let's say this worker A crashes, so what would be happen in that case? So in that case, since this lease is valid for 10 seconds, so etcd, what it does is, it automatically removes this key. So this key would be removed, and then once this key is removed, what etcd would do is, it would notify the other nodes. What are the other nodes? The worker B and worker C, right? So it would notify these nodes, and these nodes again would be competing for leadership election, and again the same process. So if you see, this is safe, automatic, and fault tolerant leader election has been happening via etcd cluster. So this is how the leader election is happening in etcd. Now the fourth problem is dynamic configuration. So modern systems need configuration changes without restarting services. So for example, the feature flag, if you want to enable any feature, if you want to change any rate limits, if you want to change any endpoint, if you want to change database credentials, right? So you can store that information also in etcd cluster. So for example, for production database, you have the different URL. For staging database, you have the different URL, right? So you can maintain these dynamic configurations in etcd cluster. So if you hard code configuration into the services application.properties, this is the practice we usually follow, right, in Spring Boot, right? So what we do is, we make the property in application.properties, and later on, if we want to change it, we can just tweak the property to true or false based on our requirement, and then again we need to basically restart the service. So that is slow and risky, but etcd solves this problem using the watch mechanism, right? As and when this configuration is changed or updated, so etcd notifies automatically to the instances, so that instances can update that configuration in its own memory and can do the operations accordingly. So this enables real-time configuration management. Now the next problem in distributed system is the service discovery. In microservices, services need to find each other. So for example, these are the four services, right? If they need to talk to each other, they should know the IP address. And in cloud environments, IP addresses change. When you see the Kubernetes, the pods can be scheduled on any of the node, right? Containers restart, pod schedule, right? So you can't hard code IP addresses into these services. So without etcd, how it would be happening? So if every service has to store each other address locally, things would start breaking, right? So but with etcd, what you can do is every service can register itself in etcd with a lease. So for example, this is the payment instance. So this service would be registering in etcd with a key like this: services payment and instance 1 is equal to this IP 10.0.0.25. and if this service crashes, this lease automatically expires, so the key would automatically be deleted. Now the registry always reflects reality. Now if the request comes to the payment service, but in payment service via etcd, we know that which are the instances which are healthy, and the request would be forwarded to only those healthy instances, right? So it helps in that as well. The next problem in distributed system is the cluster state management. I will talk about this with a real example, how Kubernetes uses etcd to store cluster state management. But these are the various reasons why you need etcd. Before understanding how Kubernetes uses etcd, firstly let's understand how etcd works internally. So what it happens is etcd also uses a vol statement similar to database. So it's a kind of write ahead log file. Why we need that? For durability. So what would be happening is, as and when the write operation comes to this etcd, so what it does is it firstly writes into its vol as a part of its persistence mechanism to guarantee durability and consistency, and then it would be replicating the data to the other nodes which are available. Now in etcd, what we have is along with vol, because whenever etcd comes up or we are starting the etcd, does it have to read the vol file again, the complete vol file again? No, because it's a long huge vol file. So if etcd has to read the complete vol file on restart, so it would be a very slow startup process. So what it does is it has this vol, and these vols on periodic time period it would be storing in this vault db. So internally etcd stores the data into the vault db, right? So as and when the write operation comes, the write operation gets persisted into the wall, then replicates into this machines, and then it would be writing this data into the vault db. This ensures crash recovery, strong consistency, and durability of committed reads. So even though let's say this entry is not present in the vault, so but etcd knows what was the last offset this vol file has been written into this vault db. So it basically replays the vol file from that location and stores into this vault db. And again etcd periodically creates snapshots. So for example, this vol file could be coming huge with the kind of request the etcd is receiving. So what it does is it creates periodic snapshots to truncate the vol and prevent it from growing indefinitely, because we don't need all the data, because it's a kind of appending log file, right? So we can remove the old data as and when this snapshot is being created, but you can tune this snapshot frequency. And internally, why etcd is so fast? Because it exposes the grpc api to get the data from it. That's how the etcd works internally. So that's all from this video. Please do like, subscribe, and share my channel with your teammates and other friends. So in the next video we will discuss lot more internals, how Kubernetes uses etcd, how Kubernetes maintains the cluster state in etcd, and the next video would be fun to watch. So stay tuned. Thanks for watching. See you in the next video.